calculate the demand factor for commercial kitchen equipment, you'll need to consult Table 220.20 in the National Electrical Code. This table provides demand factors for various types of appliances and equipment. According to Table 220.20, the demand factor for electric ranges is 80%. This means that an electric range with a nameplate rating of 3 kilowatts will have a demand of 3 kilowatts times 0.8, which equals 2.4 kilowatts. The demand factor for water heaters is 100%. This means that a water heater with a nameplate rating of 20 kilowatts will have a demand of 20 kilowatts. The demand factor for deep fryers is 75%. This means that a deep fryer with a nameplate rating of 3 kilowatts will have a demand of 3 kilowatts times 0.75, which equals 2.25 kilowatts. Therefore, the total demand for the example commercial kitchen equipment would be 2.4 kilowatts plus 20 kilowatts plus 2.25 kilowatts, which equals 24.65 kilowatts. Since there are 5 units, the total demand would be 24.65 kilowatts times 5, which equals 123.25 kilowatts. However, it's then necessary to apply the demand factor from Table 220.20 to account for the diversity of the load. The demand factor for 5 units of kitchen equipment is 70%. Therefore, the total demand would be 123.25 kilowatts times 0.7, which equals 86.275 kilowatts. Therefore, the demand factor for the commercial kitchen equipment would be 86.275 kilowatts. Let's delve deeper into understanding demand factors and how they are applied using the National Electrical Code, specifically focusing on Table 220.20. We will walk through an example step by step. The National Electrical Code, or NEC, provides guidelines and regulations for electrical installations to ensure safety and consistency across various applications. Table 220.20 within the NEC is specifically dedicated to demand factors for commercial cooking appliances and other kitchen equipment. Demand factors are reduction factors applied to the total connected load of a group of similar loads. This accounts for the fact that not all appliances will operate at their maximum rated capacity simultaneously. Understanding and properly applying these factors is crucial for accurate electrical system design and to avoid oversizing equipment, which can lead to unnecessary costs and inefficiencies. Firstly, to begin the calculation, identify all the commercial cooking appliances and equipment that will be connected to the electrical system. For each appliance, determine its nameplate rating in kilowatts, which indicates the maximum power the appliance can draw. This information is typically found on a label affixed to the appliance. Secondly, consult Table 220.20 in the NEC to determine the demand factor for each type of appliance. The demand factors are typically expressed as a percentage. For instance, electric ranges may have a demand factor of 80%, while water heaters might be at 100% and deep fryers at 75%. These percentages are based on statistical data and industry experience reflecting the likelihood of simultaneous operation at full capacity. Thirdly, apply the demand factor to each appliance's nameplate rating. For example, if an electric range has a nameplate rating of 3 kilowatts and the demand factor is 80%, the demand contribution of that range is 3 kilowatts times 0.8, resulting in 2.4 kilowatts. Similarly, for a water heater with a 20 kilowatt rating and a 100% demand factor, the demand contribution is 20 kilowatts. For a deep fryer rated at 3 kilowatts with a 75% demand factor, the demand contribution is 3 kilowatts times 0.75, equaling 2.25 kilowatts. Fourthly, sum up the individual demand contributions of all appliances to determine the total demand before diversity. This is the sum of all the adjusted loads of each appliance after applying their respective demand factors. In our example, this would be 2.4 kilowatts plus 20 kilowatts plus 2.25 kilowatts, totaling 24.65 kilowatts. Fifthly, consider the number of units of kitchen equipment. If there are multiple identical appliances, such as 5 ranges each with a demand of 2.4 kilowatts, multiply the demand contribution of a single unit by the number of units. For example, 24.65 kilowatts times 5 units results in 123.25 kilowatts. Sixthly, apply an additional demand factor from table 220.20 based on the total number of appliances. This factor is applied to account for the diversity of the entire load, recognizing that not all appliances will operate at their maximum demand simultaneously. For instance, if the demand factor for 5 units of kitchen equipment is 70%, you would multiply the total demand before this diversity factor, which is 123.25 kilowatts, by 0.7, resulting in 86.275 kilowatts. This final value, 86.275 kilowatts, represents the calculated demand for the commercial kitchen equipment. This is the value used to size the electrical service, conductors, and overcurrent protection. It is important to note that the specific demand factors in Table 220.20 may vary based on the type of equipment and the number of units. Always refer to the latest edition of the NEC and consult with a qualified electrical engineer or inspector to ensure accurate and compliant electrical system design. Proper application of demand factors not only ensures safety but also optimizes system efficiency and reduces costs. Now, let's break down some key considerations when using Table 220.20. Firstly, understanding the scope of Table 220.20 is crucial. It primarily applies to commercial cooking appliances and kitchen equipment. It may not be applicable to other types of loads, such as HVAC systems or lighting, which have their own specific requirements and demand factors outlined elsewhere in the NEC. Secondly, accurately identifying the appliance type is important. Table 220.20 categorizes different types of appliances, such as ranges, ovens, fryers, and water heaters. Each category may have a different demand factor. It's important to correctly classify each appliance to ensure the appropriate demand factor is applied. Thirdly, recognizing the number of appliances is crucial. The demand factor often depends on the number of appliances. As the number of appliances increases, the diversity of the load typically increases, leading to a lower demand factor. This is because it becomes less likely that all appliances will operate at their maximum capacity simultaneously. Fourthly, being aware of the footnotes and exceptions within Table 220.20 is necessary. The table may have footnotes or exceptions that modify the demand factors under specific conditions. For example, there may be adjustments based on the type of control system or the operating characteristics of the equipment. Fifthly, considering other applicable NEC articles is important. Table 220.20 is just one part of the NEC. Other articles, such as those covering conductor sizing, overcurrent protection, and grounding, must also be considered to ensure a complete and compliant electrical installation. Sixthly, consulting with qualified professionals is always a good idea. Electrical system design can be complex, especially in commercial settings. Consulting with a qualified electrical engineer or inspector can help ensure accurate calculations and compliance with all applicable codes and standards. Seventhly, keeping records of calculations and assumptions is crucial. Documenting the calculations, including the nameplate ratings, demand factors, and the resulting demand load, is important for future reference and for demonstrating compliance to inspectors. This documentation should also include any assumptions made during the calculation process. Eighthly, regularly reviewing and updating calculations should be done when changes occur. Electrical loads can change over time as new equipment is added or existing equipment is replaced. It's important to regularly review and update the demand load calculations to ensure the electrical system remains adequate and compliant. Let's consider some example scenarios to further illustrate the application of Table 220.20. Scenario 1 involves a small restaurant with 3 electric ranges, each rated at 5 kilowatts, 2 water heaters, each rated at 10 kilowatts, and 1 deep fryer rated at 4 kilowatts. First, determine the demand for each range. Assuming a demand factor of 80% for electric ranges, the demand for each range is 5 kilowatts times 0.8, which equals 4 kilowatts. With 3 ranges, the total demand for the ranges is 3 times 4 kilowatts, equaling 12 kilowatts. Next, determine the demand for each water heater. Assuming a demand factor of 100% for water heaters, the demand for each water heater is 10 kilowatts. With 2 water heaters, the total demand for the water heaters is 2 times 10 kilowatts, equaling 20 kilowatts. Then determine the demand for the deep fryer. Assuming a demand factor of 75% for deep fryers, the demand for the deep fryer is 4 kilowatts times 0.75, which equals 3 kilowatts. Then calculate the total demand before diversity. This is the sum of the demand for the ranges, water heaters, and deep fryer, which is 12 kilowatts plus 20 kilowatts plus 3 kilowatts, totaling 35 kilowatts. Next, apply the diversity factor from table 220.20 for the total number of appliances. Assuming a diversity factor of 70% for 6 appliances, the total demand is 35 kilowatts times 0.7, which equals 24.5 kilowatts. Therefore, the calculated demand for this small restaurant's kitchen equipment is 24.5 kilowatts. In scenario 2, consider a large commercial kitchen with 10 electric ovens, each rated at 8 kilowatts, 5 dishwashers, each rated at 6 kilowatts, and 3 ventilation systems, each rated at 2 kilowatts. Firstly, determine the demand for each oven. Assuming a demand factor of 65% for electric ovens, the demand for each oven is 8 kilowatts times 0.65, which equals 5.2 kilowatts. With 10 ovens, the total demand for the ovens is 10 times 5.2 kilowatts, equaling 52 kilowatts. Secondly, determine the demand for each dishwasher. Assuming a demand factor of 90% for dishwashers, the demand for each dishwasher is 6 kilowatts times 0.9, which equals 5.4 kilowatts. With 5 dishwashers, the total demand for the dishwashers is 5 times 5.4 kilowatts, equaling 27 kilowatts. Thirdly, determine the demand for each ventilation system. Assuming a demand factor of 100% for ventilation systems, the demand for each ventilation system is 2 kilowatts. With 3 ventilation systems, the total demand for the ventilation systems is 3 times 2 kilowatts, equaling 6 kilowatts. Fourthly, calculate the total demand before diversity. This is the sum of the demand for the ovens, dishwashers, and ventilation systems, which is 52 kilowatts plus 27 kilowatts plus 6 kilowatts, totaling 85 kilowatts. Fifthly, apply the diversity factor from table 220.20 for the total number of appliances. Assuming a diversity factor of 50% for 18 appliances, the total demand is 85 kilowatts times 0.5, which equals 42.5 kilowatts. Therefore, the calculated demand for this large commercial kitchen equipment is 42.5 kilowatts. Let's look at specific considerations for different types of appliances, starting with electric ranges. Electric ranges are common in commercial kitchens and typically have a demand factor of around 80%, but it can vary based on the number of ranges. Factors that can influence the demand factor include the type of controls, such as thermostatic controls, and the operating habits of the kitchen staff. For water heaters generally have a demand factor of 100%, as they are often required to maintain a constant water temperature. However, some water heaters may have energy-saving features that can reduce their demand. For deep fryers typically have a demand factor of around 75%, as they cycle on and off to maintain the oil temperature. Factors that can influence the demand factor include the type of fryer, such as gas or electric, and the volume of food being fried. For ovens can have varying demand factors based on their type, such as convection ovens or deck ovens. The demand factor can also be influenced by the type of controls and the operating habits of the kitchen staff. For dishwashers generally have a higher demand factor, as they often operate at or near their maximum capacity during peak hours. Factors that can influence the demand factor include the type of dishwasher, such as conveyor or under counter, and the volume of dishes being washed. For ventilation systems are critical for maintaining air quality in commercial kitchens and typically have a demand factor of 100%. However, some ventilation systems may have variable speed controls that can reduce their demand during off-peak hours. Understanding these specific considerations for different types of appliances can help ensure accurate demand load calculations and proper electrical system design. Remember to always consult the latest edition of the NEC and work with qualified professionals to ensure compliance and safety. Additionally, maintaining accurate records of all calculations and assumptions is crucial for future reference and for demonstrating compliance to inspectors. Regular review and updates of the calculation should be performed whenever there are changes to the electrical load or equipment in the kitchen. These steps will help ensure that the electrical system remains adequate, safe, and efficient.